So today we are starting a new unit, which is logarithmic functions. We're going to start with exponential functions because logs are inverses of exponents. We are doing a little bit of investigation, you can try and do it yourself and then compare, or you can just watch this video and see if you come up with any questions after you watch it. So the first thing that we do is we want to graph the exponential function. And the basic exponent function is 2 to the power of x. The first thing that we're going to do is we're going to take the points, any random points really. We want to take the positives and the negatives because we want to see how it influences the answer, the solution. When x equals 4, 3, 2, 1, x equals 0, negative 1, negative 2, negative 3, we're going to get these y's for them. Now what we're going to do is we're going to plot the x and y and connect the dots, and this is the graph that we're gonna get as a result, this wider one, 2 to the power of x. So let's look at the domain. Domain goes from left to right on the x, so as you can see we can go indefinitely to the left and indefinitely to the right. For y, for range, y is YER, all real numbers. However, see, this graph does not go below the 0. So for any exponential function, you have a horizontal asymptote. So y has to be greater than 0 in this case. Equation of the asymptote is y equals 0. The x-axis becomes your horizontal asymptote. Y-intercept is 1. This is happening because any number to the power of 0 will give you 1. X-intercept is none. You're not touching the x-axis, you're just approaching it really closely, so there'll be no x-intercept. The function is increasing. It goes up from left to right, so the values of x get bigger and the values of y get bigger as you go from left to right. And behaviors. When your x goes towards negative infinity, your y becomes smaller and smaller and approaches 0. And as your x moves towards positive infinity, your y gets bigger and it approaches positive infinity. Okay, what happens if we change the base? So this is, our base becomes now 3, and here our base becomes 5. So this is what came out. Alright, so if we compare though these three functions, 1, 2, 3, even though they have different widths, the main characteristics are still the same. They still pass through 1. All three of them are non-linear, and they are all increasing. They go from negative to positive, from left to right. What happens if our base is a fraction? If we have 1 over 2 instead of 2 for our base. For the function y equals 1 over 2 to the power of x, the domain is XER. Again, it's all real numbers. It continues indefinitely from negative to positive x. Range is YER, and our asymptote still stays. It has to be greater than 0. Y equals 0 is the horizontal asymptote, and it's on the x-axis. Y-intercept is still 1. X-intercept non-existing because we're not crossing the x-axis. The function in this case though will be decreasing. So this is the y equals 1 over 2x. As you can see, it's going down. So what happened to the graph? It got flipped over the y-axis. So this was our 2 to the power of x, and this is our 1 over 2 to the power of x. The same characteristics, except the graph is now decreasing. It's going down from left to right, and it's flipped over y-axis. Both are still non-linear. They have y-intercept at 1, have y equals 0 as horizontal asymptote. The difference is that they are decreasing. One is increasing, the other one is decreasing, and 1 over 2 to the power of x is a reflection of y equals to 2 to the power of x in the y-axis. The common point is 0, 1. It's the y-intercept. Why? Because any base to the power of 0 will give you 1. remember this. I think you were learning this in grade 9 still, and it's really important for this unit to remember that anything to the power of 0 will give you 1. Now let's look at the inverses of these exponential functions. Remember, in an inverse is when you flip x and y values in the function. So, if in the tables you had x equals 4 and y equals 16, in the inverse, x will equal 16 and y will equal 4. So now for x here, you will put 16, and for y you will put 4, and then you plot them. The inverse is the reflection of the original graph over the y equals x line. And you can see that these two graphs are symmetrical about y equals x. What changes though? Really, because you flip x and y, the only thing that changes is your properties of x become properties of y, and your properties of y become properties of x. And the same characteristics stand except they flip between x and y. So now, look at this. When the domain was xer, exponential function, it now becomes the range of the inverse. And the range of the exponential now becomes the domain of the inverse. So the domain of the inverse is now xer, and x has to be greater than 0, not y. And now we don't have a horizontal asymptote, but instead we have a vertical asymptote at the y-axis, right here. So your graph approaches y-axis but does not touch it. Range is all real numbers. You can go from the bottom to the top along the y-axis as long as you want. Equation of the asymptote is now x equals 0. And y-intercept is non-existing because you're just touching the y-axis but you're not crossing it. X-intercept is 1. So you're still going through that 1, but not on the y anymore, but on the x right here, because x and y, they get switched. The function is increasing and goes up from left to right. And then behavior as x approaches 0, so as x values approach your y-axis, then y becomes greater in the negative direction. So y approaches negative infinity. Let's take y equals 1 over 2 into the power of x and do the inverse of that. So again, see, we just filled out the regular table, but now we're going to flip this and this. So your x will now become 1 over 16 and your y will become 4. And if we graph them, we're going to have actually two similar graphs. Let me scroll down. Two similar graphs, and except your y-intercept now becomes x-intercept, your horizontal asymptote becomes your vertical asymptote now. There are no y-intercepts for the inverse of the function. It only touches the y-axis but not crossing it. And the domain is x has to be greater than 0, so you can't go in the negative x or touch the y-axis. But you can go indefinitely in the direction of the positive x value. The function is also decreasing, just like the exponential sister. So 1 over 2 to the power of x was decreasing, and the same is happening to the inverse of 1 over 2 to the power of x. It's still decreasing. It's going down from left to right. The end behavior is as x approaches 0, or vertical asymptote, f of x approaches positive infinity. Values of y increase. And as x gets bigger in a positive direction, y gets bigger in the negative dimension. So this is about it. This is the summary chart, and you probably want to keep it close and available for at least couple of lessons in the beginning of the unit, just to have a reference point of what you're looking at in terms of the inverses of the exponential functions, because it just gives you the general information of the handy, okay? Either on your computer or your phone or whatever else. Again, I don't encourage you to print it, just have it somewhere so that you can access it from one of your devices. Alright, so you have the sketches, the main sketches of the functions. So 2 to the power of x, 1 over 2 to the power of x, the inverse of 2 to the power of x, and the inverse of 1 over 2 to the power of x. There you go. This is it for now, and this is you. Bring them out, don't be shy, and I can't wait to hear